When we talk about parallel lines, okay, when we talk about parallel lines, we talk about two lines that no matter how far they're extended, remember these a line goes forever, right, in both directions. So when we talk about parallel lines, we talk about two lines that no matter how far they extend, which is forever, right, they never cross. So those lines are parallel. So even if there was the tiniest little angle, you know, 0.00000001 degrees, eventually these two lines would cross, right? So parallel lines never cross. Okay, so just remember that. And it's between our math and our engineering drawings, we can solve a lot of information on a print if we understand parallel lines and we understand perpendicular lines. And that's our next line, perpendicular lines. Okay, perpendicular lines are lines, two lines that meet at 90 degrees. Okay, they meet at a 90-degree angle, and usually, well, not usually, but that perpendicular lines are drawn as two lines, like this is how you would see it in geometry or in math, right? Two lines that cross at 90 degrees. But anytime an angle of 90 degrees is created on a drawing or in a math problem, you'll see this little square where the 90-degree angle meets. Okay. Now, if this is 90 degrees, okay, and this is important to know, if you may already know this, and that's great if you do, but if this is 90 degrees, that means that this is also 90 degrees, right? Because this line and this line are perpendicular, so they have to create two angles that are at 90 degrees from one another. And we'll talk a little bit more about that in a little bit. The other type of line that we want to talk about is an oblique line. Okay, an oblique line. So an oblique line, it meets or intersects at an angle other than 90 degrees. Okay, so if I were to draw a line like this and like this, then where they meet, right, they meet at an angle other than 90 degrees. So this might be a 50-degree angle, whatever it is. So that these two lines, we would refer to them as oblique lines. All right. So it doesn't have to be 50 degrees. It can be any angle, right? As long as it's not 90 degrees. So that brings up the question, what exactly is an angle? And we know, most of us know for sure what an angle is. But just for the sake of finishing our definitions, right? An angle, okay, is a figure that consists of two lines that meet at a point called the vertex. Okay, so anytime you have two lines, okay, where they meet, see this point right here, that point right there, that's called the vertex. And often you'll see it referred to as the vertex angle. So anytime we talk about a vertex angle, that's where two lines, they meet. And it's any two lines, right? This is the symbol for perpendicularity, right? We have this line meets this line at 90 degrees. But this point where they meet, right here, right in there, that's the vertex angle, right? This here, right in there, right? That's the vertex angle. Okay, so there's other angles that we talk about, but this is the vertex angle. The size of an angle is determined by the number of degrees that one side of the angle is rotated or one ray is away from another ray. And these two lines here, we can refer to these as rays, right? There's this vertex angle. It starts at this point, right? This line ends at this point or starts at this point. So this line here is actually a ray, right? And this line is a ray, right? Those two lines are both rays. So the size of the angle is determined by how far away one ray is from the other, right? The length of the line, though, and remember this, moving forward in geometry and as we get into trigonometry, the length of a line does not determine its angle. Okay, the angle, this line could be 3 times as long as I've drawn it. It does not change this angle. Okay, so the length of a line has no bearing on the angle itself.